So this is ELC 131, Circuit Analysis 1, and this presentation will discuss electric circuits. Now, in order to have an electric circuit, we have to have three things. One is a source of potential difference. Or a voltage source. We have to have a path for current, and we also have to have some sort of electrical load. Now, the electric load could be an incandescent bulb. It could be, of course, an LED. It could be a motor. It could be a heating element. But we have to have some reason for there being voltage and current. There has to be something that we're going to perform some work on. So let's look at a pictorial diagram of an electric circuit. Again, we have to have some source of potential difference, and in this case, it's a single cell. Remember from our previous discussions that the positive terminal is the anode, the negative terminal is the cathode. And we have to have, again, some sort of electrical load. And in this case, we're going to have or use a simple incandescent bulb. And of course, then we also have to have some path for current to be able to flow from the anode to the cathode. Remember from our last discussion, we really know that the electrons are flowing from a point of surplus to a point of deficiency. However, in here, we're always going to describe current as flowing from positive to negative. This is called conventional current flow. Now, in electricity and electronics, we don't represent our circuits using pictorial diagrams. We represent our circuits using schematic diagrams. And we use a set of approved schematic symbols to represent these circuit elements. So the schematic symbol for a single cell is as shown. One longer line represents the positive terminal, one shorter line represents the negative terminal. The incandescent bulb is represented with this schematic symbol. And of course, the connection from these points are simply lines connecting these points. Now, in our schematic diagram, as we call them, we're going to always have to denote what this voltage is. We're going to give it a reference name, and we're going to refer to this simply as VS, standing for source voltage. And of course, this lamp over here, we're going to call it lamp. We'll just call it lamp, yeah. So in our schematic diagram, we always have to not only represent these circuit elements using an approved or recognized schematic symbol, but we have to give reference IDs to these elements in the circuit. Now, with my electric circuit, I could increase the voltage applied and increase the current flow by connecting two sources in what we call a series aiding configuration. So the voltage from this cell and this cell will add together, therefore increasing the applied potential difference. This will also increase the current flow, and it'll also increase the brightness of the bulb. Now, representing this schematically, we would show both cells connected as shown to where their voltages add together. So this schematically represents these two cells connected in a series aiding configuration. As we progress in this class, we'll see that this schematic symbol, let's start over again. Is also used to represent any kind of DC voltage source. Doesn't matter the magnitude of this DC voltage source, but this schematic symbol will always be used or will be used to represent a DC voltage source. So again, we looked at the requirements for an electric circuit, source of potential difference, a path for current, and some sort of electrical load. We looked at the configuration of a simple electric circuit, and we looked at how we represent these electric circuits with schematic diagrams.